Hello. This lesson is to help you with multiple representations. In algebra, we like to take data and represent it in multiple ways. Sometimes we represent it verbally. Sometimes we represent it in a table, a graph, an equation, and here we're going to add either more also verbally. So let's go ahead and begin. We begin by looking at the representation that was given to us. In this case here, we were given a word problem, so it was given to us in words. So we want to take those words in the diagram they give us and represent that data starting with the table. So let's go ahead and look at the word problem first. In the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, equation, and a graph. So we are going to start with the table. First, we need to talk about what perimeter means, because they want the relationship between the number of rectangles, so the number of rectangles, here we have one, and its perimeter. Perimeter is a distance all the way around a figure. So perimeter, all we need to do to find perimeter is add all the sides. And so that's what we would do first. We would add all the sides of each figure formed by the rectangles. So here we have 6 plus 1. The opposite side here would be 6 as well, and then the opposite side here would be 1. So 6 plus 1 is 7, plus 7 more would be 14. So the first one has a perimeter of 14. These two rectangles put together have a perimeter of 6. Down here we'd have 1, 1, 6 again, and then 1, 1. So this is 12 here, 13, 14, 15, 16. Remember that we are looking for perimeter, and again that means to add all around the edge. Okay. So here we would have 12, 13, 14, 15, 16. Same thing here. We want to find the perimeter. That's the distance all the way around this shape. So these two sides would be the same. There's 3 up here, so there'd be 3 down here. 12, 13, 14, 15, 16, 17, 18. If you notice, you do have a pattern going here. Algebra is all about looking for those patterns. So the next one should be 20 if we follow the pattern. They increased by 2. So again, you want the distance all the way around. So these two sides are the same, and then up here we had 1, 2, 3, 4, so there would be 4 here as well. So 12, and then 4, that's 16, 17, 18, 19, 20. So to take this information and record it so that we can see more patterns that have developed, we can put it on a table. We can organize that data in a table. The relationship they wanted was the rectangles and the perimeter. So I'm going to use this column here to record the rectangles. So I'm going to use an R for rectangle, and I'll use this column here to record the perimeters. And again, we're just taking this information and recording it on an organized list. So one rectangle had a perimeter of 14. 2 rectangles, when we looked at the perimeter of 2 rectangles, it was 16. 3 rectangles, 18. And then 4 rectangles was 20. So now what we want to do is, the table is really good because it helps you to see even more patterns. It also helps you to see the relationship between rectangles and perimeter. And so in order to see that, though, we need to see what kind of function is this. This is a function. We need to see, is it a linear function, quadratic function, exponential function? There's different kinds of functions. So the best way to tell is by looking at the picture of it. So we're going to take this data and we're going to present it now on a graph. Now, since you only have positive numbers here and positive numbers here, it's good to make your graph by putting your x-axis here at the bottom and your y-axis here on the side. So again, this is going to be your x-axis, where we're keeping track of the rectangles. And then you have your y-axis, where you're keeping track of your perimeter. So we're going to take those numbers, which are now points that we can use to record here. These end up being points. So the first point is 114. And I'm going to record it on this graph. Now I do want to set up my graph so that way I can fit these numbers, because these numbers here are pretty big. Now the x's are pretty low. Remember, this is our y here. So I think the best thing we could do, since we have 10 little squares here and we only need to record up to 4, is maybe we could, I don't know, skip and go by 1, just to kind of spread it out evenly. See, we're able to get up to 5. Here we need to go up to 20, and I have 10 lines going up, so maybe a good thing we could do is skip and go by 4s. That would put 4 here, skip that one, put 8, skip that one, put 12, 16, and 20. So let's record our first point. Our first point is 114. So 114, let me use a different color to put my points. 114, you would go to the right 1 for the x, and then go up to 14 for the y. 216, that's another point. This is 216. Take that, record it on your graph, 2, and then up 16. 318, this is another point that we can use, 318. So go to the right 3, go up 18. And then the last point is 420. And so again, go to the right 4, go up 20. So if you notice, these points are creating a linear function. If you connect them with a straight line, the ruler, you can see that it does make a straight line. And so we call that a linear function. So since it's a linear function, then we're able to see that, well, all linear functions do have one formula in common. And that formula is the same for all linear functions. So let me pick a different color here. It's a linear function. And the formula that they all have in common is y equals mx plus or minus, sometimes it's minus b. Now you do need to know how to come up with the equations. So two of the things that you need in this formula for sure to find the equation is your m, which is your slope. So m is slope. And you need to find b, which would be the y-intercept. If you can find those two things, you're good to go. You need your m and you need your b. Your m is the slope of your line, and slope is very easy to find. There's several ways. One is by counting the rise and the run of your line, or you can also use the slope formula. So I'm going to show you how you can use the slope formula. The slope formula is m equals y2 minus y1 divided by x2 minus x1. So here you have a formula that we can use to find the m. It's our slope formula. And all we need to do is use points that are in our table. This y2 is literally referring to the second y. Because if you think about it, these are your x's, these are your y's. We graphed them over here, x, y. So when it says y2, they're talking about your second y, which is this one, minus y1. It's your first y. Down at the bottom of your formula, it's asking for the second x, so that would be this number here, and your first x, that would be this number. So you simply need to just plug them into your formula. So let's plug them in, let's see what we get. We got 16 minus 14. So 16 minus the 14. On the bottom, we want 2 minus 1. 15 minus 14, that gives you 2. 2 minus 1 gives you 1. You divide that, and you simplify to 2. So this right here is your slope. That's the number that belongs in your formula. That is the slope of your line. So we're halfway there. We just need to find our y-intercept next. We got y equals 2. The x is part of your formula. It will stay in your equation. And then here we just need to find out what the b is. The b is simple to find as well because the b is just your y-intercept. Your y-intercept is where your line crosses the y-axis. So right here at this is where your line crosses the y-axis. This is your b for your formula, which happens to be 12. So b is equal to 12. So come back over here. It's a positive 12. Use a plus sign. So plus 12. And that would be the formula for the relationship of the rectangles and your perimeter. Now you do want to take this formula and go back to your points to make sure if it did work out. We do want to go back and test our formula, test our equation, test this relationship to see if it actually works with these numbers here in our table. So I'm going to take this and I'm going to use it here in the middle column so that I can test the points. 2 times the x plus 12. So 2 times that x plus 12 must equal to that y number. So let's see if it works. 2 times 1 is 2 plus 12 gives you 14. So it works. You do want to test each one. Sometimes it'll work for one and not the rest. So 2, that's the formula, times x. Okay, here's your next x. And then plus 12. And that gives you 16. Next row, same thing. It says 2 times x plus 12, so use the same formula. 2 times 3 is 6 plus 12, 18. 2 times 4 is x plus 12, and that gives you 20. So that's what the process column is for, is just so you can test your equation, double check that it is correct. So this is our equation. This is the equation that when you plug in these x's, produce these y's. And that's what it says, y's equal to 2 times the x's plus 12. Now in the verbal description here, I just want you to use words that we have learned for x and y. We have words like independent and dependent, domain and range. So on this one, let's go ahead and use domain. That is one way you can just call your x's. Your x's can be known as your domain. And let's call the y's range. And so when we write a verbal description, we're just going to verbally describe our formula here. We just look at the formula, start at the beginning, and make a sentence using words. So the y is called the range. So we're going to start with the range equals or is, you can use the word is, 2, just write out the word 2, times, this would be multiplication here, so times the x. Well, the x is your domain. So times the domain plus, put the word plus, 12. And that's just verbally describing your formula so that if somebody sees this formula, they know exactly what it's for. And so it's basically saying that the range, these numbers here, equal to 2 times the domain plus 12. So I hope this lesson was useful. I know some of you were struggling with the multiple representations. Thank you for tuning in. This is Mrs. Santana here at Dr. Connell Freshman Academy.